Hello everyone and welcome to this question. Let's have a quick read of this. It says a block of mass 8 kg is held at rest on a rough horizontal surface, which is here. The coefficient of friction, so I'm going to highlight the key things that we need. The coefficient of friction between the block and the surface is 0.3. A light inextensible string which passes over a smooth pulley is attached to one end of the block and to other end of the particle, mass 5 kg. System is released from rest. Okay, so what we need to do, we need to find the magnitude of the friction force acting on the block, find the acceleration of the blocks, find the tension in the string. So first of all, if that's released, we got this coming down with the weight 5g. We've got that holding it back, tension. This tension is now dragging this block forward, and what's going to oppose that is going to be friction. So we've got all this motion going on, and then what we got here, the block has a weight on the table which is going to be 8g, and the table is pushing back with reaction R. I'm going to call that RB because I'm going to call B the block. Okay, so we've got all these forces happening. Now the reason why we need this, because when we're working at friction, okay, when we're working at friction, friction is less than or equal to mu times the contact force, in this case will be RB. Now because it's released from rest and there's going to be motion happening, friction is going to be active, and when friction is active it's at its maximum, so it's going to be mu times RB. And RB here, there's nothing else going up or down, we're going to say is 8g, so friction is going to be, and we've been told, here coefficient of friction to block in the surface is 0.8, so I know mu is going to be 0.3, and RB is going to be 8g. Okay, so find the magnitude of the friction acting on the block, so we can do that straight away, and our calculator, just press that through and you will get 0.3 times 8g will give me 23.5 three single figures 5 newtons. So we've done the first part. Okay, done. Next one, find the acceleration of the block. So when we find an acceleration of the block, we've got something happening here, acceleration happening here, and the same acceleration happening here. So what we got is we can make two formulas. Let's just do B here. So let's do this one first. So we got 5g coming down, tension going against it, and that's equal to Newton's second law, force equals mass times acceleration. Force equals mass times acceleration. That's the resultant force. The mass of this particle is 5 kg, so that's going to be 5a. And the second equation, what we got along here is we got tension pulling it, friction opposing it. We already worked out what friction is, so I'm just going to write it down first and I'll put the numbers in. So friction is opposing it, and that's going to be the resultant force, and that's going to equal mass of this block, which is 8 times acceleration. It's going to be going at the same acceleration. Now what we can do here is, because we've got minus tension there and a positive tension there, we can perform simultaneous equations here by adding these two. If we add those two, we'll get 5g minus t plus t will disappear, and that will be minus friction, and we'll get 5 plus 8 is 13a. Okay, and now we know that friction is 23.5, so we can say 5g minus 23.5 and divide that all by 13 will give me the acceleration. Now we know that g is 9.8 unless it states otherwise. If you put that in your calculator, you're going to get a equals 1.96 meters per second. Okay, once we got that, So we've got the acceleration of the block. Then it goes find the tension in the string, so we can just sub that value back in any of these equations. I'm just going to go for, let me have a look. So if I rearrange that, I'm just going to go for this one. So if I rearrange that, tension is going to equal, bring that to the other side, becomes 8a plus the friction, where we know that acceleration is that, so that's going to be 8 multiplied by 1.96 plus friction, we already worked that out, which is 23.5. okay, and if you put that in our calculator, you get to 3 significant figures. Always give your answer to 3 significant figures unless stated otherwise. So you go get 39.2 newtons. So that's the tension there. So we're all done.